Good morning, everyone. I'm Prince Sani from Vishwakarma Institute of Technology. So, let me first introduce my group members. So, my group members are Dilpreet Singh Sani, Aditi Sadavare, Pranav Sastrabudhe, Prince Sani, Siddharth Sadke, and Sahil Kumar. And our topic for today's presentation is aerial hand gesture using image processing. So, our project presentation includes a lot of going back and forth for our presentation to the IDE for presenting our module we used. So, I would like to call my team member Dilpreet to play our presentation video, which we have highly edited to keep it shorter than 10 minutes to respect each other's tone here. So, Dilpreet, kindly play the video for our presentation.
Greetings of the day, everyone. I'm Dilpreet from Vishwakarma Institute of Technology, Pune. Today, I'm here on behalf of my group to present our research paper titled Aerial Hand Gestures Using Image Processing. The main aim of our research paper is to explain the working of a Python module that we have created. This module is publicly available and open sourced on GitHub. You can find the link of the source code of this module at point number 4 of the reference section of our research paper. This module basically handles the detection and tracking of hands with the help of an already existing module called MediaPipe. MediaPipe is basically a machine learning module created by Google that has already fed in information on how does a hand should look like. Before we jump into explaining the working of this module, I would first like to demonstrate a very basic calculator application that we have created. This application makes use of our hand gestures module in order to interact with the application not by physical input device such as a mouse or a keyboard, but rather by using hand gestures. Like always, the code of the calculator application is also open sourced on GitHub, and the link can be found at the point number 9 of the reference section of this research paper. So I'll run the code now. Hi, this is me again. So you can see the Python code that we have created has printed a basic calculator UI on the screen. So if I raise my hand now, you can see these three dots, one on my index and one on my middle finger, and one dot in between. So this is our module that we have created. So it is detecting my hand, and I've hard coded to track the distance between my index finger and the middle finger. If you can see at the bottom of the webcam feed, you can see some numbers in hundreds. So it is basically the distance between my index and middle finger. So if I reduce the distance, you can see it has went from 100 to in a two-digit number. And I've hard coded that if the distance between these two fingers is less than 50, it should consider it as a click, and that's why it is showing the purple color line in green. So if I hover my finger over any of the button and reduce the distance between them, the program will consider it as a click. Due to time constraints, it is not possible for us to explain the whole code in this presentation. But if you want, you can always access the complete code later on GitHub. There are mainly five functions that the user can use to create their own hand gestures. I'll just explain the parameters those functions take in and what is the expected output from those functions. You can later read the research paper where we have explained in detail how those functions work and calculate the desired output. The first function is init. It has five parameters, namely self, mode, max hands, detection confidence, and tracking confidence. Out of these five parameters, the last four parameters are required by the MediaPipe module. Max hands indicates the number of hands the user wants to detect, while detection confidence and tracking confidence are percentage value of the accuracy the user wants to detect or track a hand. The second function is find landmarks. Before explaining this function, webcam feeds are videos, and videos are nothing but basically fast changing images. These images are stored in RGB format, but for the detection of hands, the MediaPipe module requires the images to be in BGR format. So this function does exactly that. It converts the RGB format into BGR format for the detection to take place, then again converts that BGR format to RGB format so that we can see the detections. Now the third function is draw landmarks. To understand the working of this function, it is first necessary to understand that MediaPipe has a predefined numbering system for all landmarks. This figure shows just that. So, in the previous demonstration where I explained the calculator app module was calculating the distance between the landmark number 8, that is the tip of our index finger, and the landmark number 12, which is the tip of the middle finger. This function takes 9 parameters, namely self, frame, results, want all landmarks, landmark 1, landmark 2, print distance, draw lines between landmarks, and click. Now I will explain each one of these parameters one by one. The first parameter is frame. It is the webcam frame. The second parameter is results. Results is nothing but the output from the previously seen function find landmarks. It is the RGB formatted image containing the detections of the hand. Third parameter is want all landmarks. Now, if I run this program with want all landmarks to false, you can see the only landmarks highlighted are the specified eighth landmark, that is the tip of the index finger, and the tip of the middle finger, that is the 12th landmarks. If I set this to true and run it again, you can see all the landmarks are now highlighted. The next parameter is landmark 1 and landmark 2. As explained earlier, eighth one is the tip of the index finger and 12th landmarks is tip of the middle finger. That's why there is a purple highlight between these two landmarks. If I change this 12 to 4 and run it again, you can see now the two highlighted landmarks are the tip of the thumb finger and tip of the index finger. Using this combinations, you can see that we can create various gestures. So like previously I was detecting the distance between index and middle finger. Now I've created a pin gesture with in which it is checking the distance between the index and thumb finger. So similarly, if the distance between these two indexes is less than 50, it will consider it as a click. So using these two possibilities, we can create various hand gestures. Now the next parameter is print distance. So if it is set to true, which it has been for a long time, you can see here the distance was getting printed. If it is set to false, this distance in the terminal will not be printed. The second last parameter is draw lines between landmarks. It is this purple highlighted lines between the two specified landmarks. And the last parameter is click at. It is the minimum distance required for the program to consider it as a click. Now the fourth function, draw landmarks z-axis, is very similar to the previous function. Instead, in this function, it requires only one landmark and it gives out the distance between the screen and the specified landmark. So for example, I'll run this z-axis code. So you can see only one landmark is highlighted over here. And if I bring this index finger closer to the screen at a specified distance, it will consider it as a click. Now the last function is basically a getter that gets the distance between the screen and the landmark or the two specified landmarks according to the function you have used. So these were the five main functions that we have created in our model. So the conclusion of this research paper is that we are tried to explain this module that we had created, which a user can easily use to integrate it with their own projects. So for the demo, we had explained a basic calculator app, but a user can integrate this with various other applications as well. So like the possibilities are endless over here. So I'll quickly explain the future scope of this module. The ideal goal of ours with this module is to add features like three finger swipe, open palm, closed fist, etc. type of gestures inbuilt. These functions can be created using our module even now, but we plan to make it inbuilt so that the user can call the function and the gesture will start working as intended, which has not been possible due to time constraints. We also plan to add gestures for more parts of the body, for example, face, legs, eyes, arms, full body posture, etc. The module is completely open source. You can check the link at the fourth point of the reference tab. And we would appreciate if any contribution in code, bugs, and any other future ideas. Thank you.
So thank you so much, sir.